So I'd like to thank all of you for coming to this talk. I'm sure we've all heard lots and lots about page objects. I was at the Selenium conference 2 years ago, and most of the talks actually had to do with how to do page objects better. And the diversity of the presentations has exploded since then, so I feel like I'm a little bit behind the curve. But hopefully all of you will find this useful. So when I first joined Akamai, I'd never had any Selenium experience. But we have a very large customer portal, not a whole lot of really good automation. And we decided that we would try to design page objects to get a nice automation suite up and running. But we ran into the same weaknesses that everybody else has run into over the years, mostly having to do with dynamic elements that take a long time to load and silent failures of native Selenium actions. So the slow loadable component pattern helped me with some of these things, but it didn't actually help me with being able to instruct a page object to use a JavaScript workaround when something happens to fail silently in a particular environmental combo. So I wanted to come up with an API that would allow me to make these page objects robust. And I didn't want to use if-then-else clauses to specify, for Firefox 31, use JavaScript to click this element, because that kind of boilerplate gets out of date and it's hard to maintain. And then the other problem I ran into was that I was constantly re-implementing the same types of components over and over again. So about, around the 50th time I had to implement a drop-down menu for a web page, I decided that it was time to abstract this kind of behavior into a component library of generic common UI components. So I set out to write out a few requirements for this API, and I came up with a repeatable recipe for creating new component models, and I have some examples where I can show you how that plays out. So my first requirement was that building a page object should be like putting together Legos. We run into the same UI components over and over again. We have drop-down menus. There are toggle buttons, chooser dialogues, paginators, and they all have the same basic interaction model. And to have these modeled in an abstract, reusable way would significantly reduce boilerplate code. And if you have a large collection of page objects, if you have these reusable components, you end up with a very consistent user interface for similar components, whereas if you have people just sort of doing it on the fly, you can have page objects that kind of look like Frankenstein, because people think of their menus and their paginators in a slightly different way, depending on the developer. And then the other big requirement I had was that they had to be dynamically configurable. Like I said before, I didn't want if-then-else clauses to handle silent failures for certain environmental combos. And then I wanted the approach for modeling components to be cookie cutter. That way other new developers or people joining my project would be able to follow the same kind of methodologies, same kind of object-oriented programming techniques to model something new and novel that we didn't already have a model for. And because nothing with Selenium is one size fits all, the other requirement I had was that it had to be easy to substitute a custom implementation for a component type if something was particularly unruly, that would still use the same basic interface as any other component of that type. So the specification step is pretty simple. If you have a component type, you have to identify the basic interface and interaction model, and then figure out what's the minimal state you have to specify in order to construct this generic component. And then the more complex step is actually figuring out where it fits in the inheritance hierarchy of other components. Because the intent was that behaviors that are reusable should be modeled separately so that they could be borrowed by any component that needs it, and they could be combined in ways that are useful to the person trying to model a particular component type. And then the last step is to identify what parts of that state should be dynamically configurable. And then the design involves writing interfaces for everything. The component type itself has to have a Java interface. The state bean for constructing the component also needs an interface. And then every component has a Fluent builder so that you can build the state for the state bean using a very well-known builder pattern style that I think is popular across most frameworks these days. And you need a Java interface for the configuration bean that takes settings that are dynamically configurable for your component. And then the implementation step involves writing some default concrete implementations for these interfaces. And then some of the components have reusable behavior, so there needs to be an abstract representation that can be extended by more specialized components, and then a default concrete implementation that can be used for a situation in which additional behavior is not needed. And then there needs to be a default implementation for the configuration bean. So I'm going to start with the most basic example that I thought will show you the foundation of how this all starts. And I call it the loadable. It's the parent of all components in the component hierarchy. And its minimal state is a WebDriver reference and a load timeout. The load timeout is necessary because everything in this library implements slow loadable component pattern. And the state bean takes a WebDriver reference and a load timeout, and this is how you specify the state to build a loadable. It's just a POJO with getters and setters. This is the source code. The interface for the loadable has a sensible default timeout, 30 seconds. And the loadable needs to provide access to its driver and its load timeout. So any component that implements this interface should have these methods. And the loadable bean has getters and setters for specifying these dependencies. So loadable config is the loadable configuration bean, and it's also a POJO. And the only thing that's environmentally sensitive about a loadable is the load timeout value, because things can take varying times depending on your test environment, which browser you have, what your OS is. So you'll want to be able to dynamically configure that so that you don't have to alter your source code for your component every time you need to run on a new environment. And then the other requirement for a configuration bean is that it needs to be deserializable with Jackson. And for those of you that don't know what Jackson is, it's a tool for populating beans from a JSON source or an XML source. And the intent was for these types of configurations to be file-driven so that they could be outside the source code and pulled in dynamically by an object that needs to configure itself for a particular environment, or if you have a test that's building a page object, it can pull the configuration for the version of the browser that you're running for the OS that the test is running on, and pass that data into the state bean. So all of the fields are of an optional type, and the reason I did this is because I needed to make a distinction between configuration values that are simply absent from the source or one that's explicitly null, because they mean different things, and there wasn't a good way to do that without using optional fields. And it needs to specify the type information, and the reason is that Jackson has a tough time handling polymorphism, and you're going to have lots of configurations that extend this basic configuration. So there needs to be a field on the top level configuration bean that specifies what class it is, so Jackson can instantiate it when it's reading in a configuration from JSON source. The basic interface doesn't look a whole lot different from the other state bean. It has a type field that takes the class type of the loadable config and the load timeout, which is the only environmentally sensitive feature of a loadable. And now for the builder, it has to be extensible because it needs to be extended by builders for more specialized components. And all of the setters have to return the runtime type of the builder. And the reason for this is that you don't want people using your builder to have to call any of these setters in a particular order. If you have a very complex component, you could have a dozen or more fields to set to construct it, and it gets to be burdensome for someone to have to remember the inheritance hierarchy of how to call these setters. So to do that, I have a reflexive type parameter for the interface. This is something that I actually borrowed from slow loadable component pattern. And the generic parameter specifies what the runtime type of the builder is. And the loadable builder provides assessors for the state bean that it's populating and the class of the component that it's actually building. And it allows you to set the driver and set the load timeout and then actually build the component and get an instance of it. It's a little complex. There's a lot of generics involved with this, but the idea is that it should be extensible and that the defaults will actually have much less complexity than these more abstract representations. So the loadable bean has a very simple default implementation, and I use Lombok to cut down on boilerplate code. And for those of you that don't know what Lombok is, it's this great tool that allows you to use annotations to add certain boilerplate methods that you need for most objects, like getters and setters for state fields. You can add toString and hash code and other methods that can make for a lot of frustrating maintenance burden, especially if people implement them in different ways or use different tools to generate them. And I make use of this all over the place, and I end up with classes that are actually much shorter than they would be otherwise. And anytime that a loadable bean implementation for a component can use an interface default, I use that so that someone can neglect to set a field if they don't want to and just go with the default. So this is the source code for a loadable bean, and I use Lombok to specify a getter and a setter. So what will happen when this code compiles is that at compile time, a get driver and a set driver method will be generated. And then the same case for the load timeout. It's a very short class and it's really fast to write, easy to maintain. And then the implementation for the configuration bean will be a little bit more complex, but it also uses Lombok to streamline the source code and reduce boilerplate. And it uses JSON as the external data store for all the configuration settings. So this might be a little bit scary, but JSON type info and JSON subtypes only have to be specified for this top level configuration bean. And this is a way for telling Jackson how to identify exactly what the class for a loadable config is, and it lists all of the subtypes. So I omitted all of the subtypes other than one because this would be way too long, but every time you add a new configuration that extends loadable config or one of its subclasses, it needs to be listed here in the list of JSON subtypes so that when Jackson needs to instantiate one of these subclasses, it can actually generate your bean, and you don't have to worry about the polymorphism. So the only required field is the type. This is what makes Jackson work. And then everything else is optional. And the only configurable field for your basic component is the load timeout. So it can be present or not present. So the abstract representation for the builder is the parent of all API builders. And it also uses Lombok to reduce getters and setters and other boilerplate. And it also has to be extensible, just like the interface it implements, because other builders need to extend it. And it will implement all of the methods in the loadable builder interface because its main purpose is to be extended by builders for more specialized components. And if those components need to override something in this implementation, it's possible for them to do that. You just override the method. So it has the same reflexive type parameter that the interface has, and this is because it's meant to be extensible. So you need to advertise to this class what the runtime type of the builder extending it is. And as before, I have getter for the state bean and the component class using Lombok. Don't actually have to write those methods. And the constructor is fairly simple. You just pass it a bean. So all of the setters can return the runtime type of the builder by using the generic type parameter. You cast your instant to the runtime type, and this frees the users of your builder from knowing what order to call their setters, and this is very useful when you have a dozen or more fields to specify. And the builder for your basic component basically allows you to specify the driver and the load timeout, and that's the state you need to specify in order to construct this component. And I don't have the source code in the presentation for the factory, but I designed the abstract builder to make it possible for someone who wants to have their own custom factory implementation. All you have to do is override the get factory method and return your implementation of the factory interface. But my default implementation uses reflection, and what you do is you pass the state bean after you've populated it with the builder and the class of the component you want to build to the factory using its create method, and the factory will find a constructor for the component that takes that bean as a parameter. So this is how all of this fits together. Every component has to specify a single argument constructor that takes that bean of that type to build it. So the default implementation is very simple. It extends the abstract implementation. You don't need the reflexive generic type parameter because it's not going to be extended. And it only needs to specify a constructor because all of the methods from the interface are already implemented. So it's a very simple class, and it has only one generic type parameter. It's like creating an array list, so it's simple for your end users. Once you get to your default implementation, all they have to do is say what the class is of the component they want to build, and then everything else just is based on the default in the API. And the constructor takes no argument because it just uses the default bean implementation. So now we go to the abstract implementation of a loadable component, and all components extend this class in the API. And like the rest of the classes, it uses Lombok to cut down on boilerplate. It uses the slow loadable component pattern, so there's a load and is loaded method defined. And it assumes that child classes annotate all of their web elements with page factory. So most of my system is based on using find by locators because I find that to be convenient and easy to maintain. But it's possible for someone who doesn't like to use those to override the load method. And you don't have to assume that your locators are all find by. But I designed this so that it's easy to just implement page factory in all of your classes, and the load method for abstract loadable will invoke page factory initialize elements, and then every element that you define in child classes with find by will be initialized by this method. And then the other requirement is that this abstract representation of a loadable has to provide a means to query your configuration service for configuration by ID. And the reason for that is that classes extending abstract loadable will have subcomponents that they need to retrieve configurations for. So this is implemented at the top level. Anyone extending this class doesn't need to worry about that, and if they have a subcomponent like a drop-down menu that it needs to find a configuration for, there's a method to query the service by a string ID. So the abstract loadable implements the loadable interface, and Lombok provides the getters that are required by that interface. And there's a constructor that takes the loadable bean as a parameter, and this is how all of the state for this component is specified. It pulls it off of the bean, and the load method will initialize all of the annotated web elements using page factory. And there's a get configuration service method that can be overridden. If someone wants to have their own custom configuration service, they can develop an implementation of the config service interface, and the get config method gets the configuration service by calling get config service, and that takes a string ID and will get the profile for the current environment and query it for that particular configuration. And if it doesn't exist, you know that there's no environment specific things that need to be configured for your component or subcomponent. So my default implementation, or my interface, just needs a method to set the profile and a method to query the service for a configuration by ID. It's a very simple interface. And my default implementation is actually a singleton class, and I use a pattern that I found on Stack Overflow that seems to be pretty popular. has a static assessor method for the singleton instance. And this default implementation expects all configuration profiles to be located in the resources page object config folder. I have a Maven project, so I put all of my configurations in this folder. And you set the profile by file name. And it expects that the JSON source for a configuration profile is a map data structure. So the implementation uses Lombok to get the profile. I can't use Lombok to set it because there's some side effects involved. And it will read a configuration profile and populate a hash map with string IDs. And this is how the profile is set. Pass it in a file name, and then the default implementation will instantiate a Jackson object mapper. And you have to actually tell Jackson what the type of your map is using this map type. This is how Jackson handles polymorphism and polymorphic collection types. And it just looks for the configuration file in that folder. And there's some try-catch blocks here that I cut out because they're too long. But obviously you'll get exceptions if the file doesn't exist. And then it takes in its JSON source and populates the hash map with all of the IDs for each object configuration. And when you need to get one of those configurations, you tell it what the ID of the configuration is, and it will see if there actually is one. So this is an example, JSON source of a configuration. This is a map data structure. The kinds of keys I use are basically the class names of the components. I find it convenient to do that, but you could use any way of identifying configurations that you want. And I lost my place. So this is an example. So there's 3 configurations here that have environment-specific load timeout values, and you can imagine that there's a class called SomeLoadable, some other loadable, yet another loadable, and this is how I identify the dynamic configuration for a particular component. So that's the basic top-level implementation. So now we're going to get into something a little bit more interesting where we have components that have actual behavior. And the example that I've chosen is something that's expandable, and this is a component that you can hide or make visible by clicking on some assessor element. So this is actually a little bit more complicated because it involves modeling behavior that's reusable by many other component types. So the basic specification is that an expandable component has toggleable visibility, so you can show it and you can hide it. And one thing to keep in mind is that components that can be dismissed from view can't necessarily be accessed. And an example of that are announcement dialogues that appear on a page when you first load it, pop-up ads that you can dismiss. So you have to be careful to make sure that the accessible and dismissible behavior are reusable in a way that allows component types that are only accessible or only dismissible can use it, and they don't have to inherit behavior that they don't need or isn't relevant to them. And then components that can be accessed or dismissed via user interaction need a mechanism for polling their visibility status because they're dynamic. And you'll want to be able to determine whether or not your expand or collapse action was actually successful. And then the last thing is an expandable component actually has a content pane that is visible when it's expanded and not visible when it's collapsed. So we're starting to think about design now. So a playable component needs to be separated out as a different component type because lots and lots of components need to be polled for some kind of status change. And then any component that has a content pane is also something that could be reused by lots of more specialized components, so that needs to be separated out. And then the accessible and dismissible behavior need to be modeled separately because not all components are both. And then some other things to keep in mind. It's possible for controls to access and dismiss components to be hoverable. They may not be visible until you move your mouse over it. And then the native hover and click commands are prone to silent failure in some environments. So the use of JavaScript workarounds to hover and click these elements needs to be dynamically configured for these objects. And then once you have all of this infrastructure built in place, you can use marker interfaces that extend the interfaces for accessible and dismissible components to specify components that are both. And if you don't know what a marker interface is, it's basically an empty interface that extends multiple interfaces. It's just a way of declaring a type that says, I'm this and that and that and that too. So the playable interface, basically, you just need a polling timeout and an interval, and then sensible defaults. So the default for polling timeout would be 30 seconds, and it will poll every second for a state change. And then the bean for specifying a playable component basically needs to provide getters and setters for setting this polling timeout and the interval. And then the configuration bean allows you to dynamically specify the polling timeout and interval based on environment. And then the builder, just like the loadable builder, has setters that will set the polling timeout and the polling interval. And it extends the loadable builder interface, so it inherits all of the methods for setting the driver and setting the load timeout for initially loading a component. And then, I apologize for some of these horrible names. Element wrapper bean is actually for a content pane element. So it has a setter for setting the content pane and a getter for retrieving it. And the builder allows you to set that before you construct the component. So everything's based on Selenium. Whenever you're constructing these components, you have some class that has a locator for these elements, and it passes, the element into the builder, and it gets set in the state bean, and the component gets that data when it's constructed. So the accessible bean. So this is for a component that can be accessed. And generally you have an element that you click to make it visible. So you need to set the element that you click, and you need to be able to have access to it in order to build this component. And then mentioned before that some of these controls can actually be hoverable, and they have to be hovered before they can actually be clicked. So there's a Boolean value that you set to indicate whether or not this component is that type of component. And you can specify whether or not to hover with a JavaScript workaround or to click with a JavaScript workaround. So this is what allows you to build a component that can be affected by a file configuration that says, okay, well, for Firefox 31 on Linux, you actually have to use JavaScript to perform these actions, and the component, when it's constructed, will be populated with values from a configuration if it exists for this component in that environment. And if it doesn't exist, then it'll go with the defaults. And the defaults are basically that it's not hoverable and you're not using any JavaScript workarounds. And the configuration bean allows you to set those dynamic features. And the ones that are sensitive to environment are the need to use the JavaScript workarounds for hovering and the JavaScript workaround for clicking. And then the builder looks like the other builders that you've seen. There are setters that return the runtime type of the builder. And the dismissible bean, this is for a component that can be dismissed from view. It doesn't look all that much different from the accessible bean. It defines a playable component that has a content pane, and you need to click an element to dismiss it. Sometimes that element is hoverable, and you'll want to be able to specify whether or not to use JavaScript for certain types of environments. And the configuration bean, just like the one for accessible components, allows you to specify those environment-specific behaviors, which is the workarounds to use Java for hovering and for clicking the dismisser that will actually hide the component from view. And the dismissible builder looks a whole lot like the accessible builder, just provides setters for setting these values in the state bean. So here are the marker interfaces that I was talking about. So we've modeled dismissible and accessible behavior separately because not every component that is one is actually the other. So the marker interface, and also this is another horrible name, and I'm sorry for this, I couldn't find a better thing to call it. It's called toggleable visibility bean, and it extends the interfaces for dismissible bean and accessible bean so you can set the state for a component that's both. And the configuration for this type of component extends both the accessible config and the dismissible config. And the builder extends both the builders for accessible and dismissible components. And finally, we get to expandable. So an expandable component extends the pollayable interface. This is a component that has a dynamic state change that needs to be polled. And the basic interaction interface is that you want to be able to expand it, you want to collapse it, and you want to know if it's expanded or collapsed. So the implementation involves some dependencies on the other types of components that we've talked about. It depends on pollayable, because this is a dynamic component, and it depends on the element wrapper, because it has a content pane. And the expandable needs to have an abstract representation that can be extended or customized by other classes, and then a concrete implementation for situations where someone's quite happy to use the default. And this component can be extended by more specialized component types, and we'll talk about one after this. So the abstract pollayable component is very simple. You just need to have access to the load timeout in the interval, and the constructor takes the bean with the state values for the polling timeout in the interval. And then the default implementation is very simple. It doesn't have anything other than an isLoaded method, and there's nothing to check whether a pollayable component is actually loaded, so this is a do-nothing method. And this is useful for another concept that I'll talk about later called decorators that allow you to combine behaviors from many types of components without a lot of extra code. And it gets around the limitation of being able to inherit from only one parent class. And the abstract content pane basically just needs to give you access to its container element. And it's loaded if the container is visible. So abstract expandable extends this content pane, and it implements the expandable interface, and it implements this interface called pollayable decorator, which I'll get to a little bit later. And this is actually how the abstract expandable can actually implement the behavior required by the pollayable interface without actually having to write any methods in that interface. And the secret sauce is in this pollayable provider here, which is a wrapper around a component that implements the pollayable interface. And this is actually where the behavior for getting the polling timeout and the polling interval are implemented. And the component is expanded if its container is displayed, and it's collapsed if is expanded returns false. So this is the expand method. So it checks to see whether this component has a hoverable control or not. And if it does, it invokes the hover control command, and it will use a JavaScript workaround if the configuration for this component specifies that it should. And then it will click the control, and then there's a little wait method that uses the polling timeout and polling interval to determine whether or not the component successfully expanded. And then if it's not a hoverable control, it just clicks the assessor, and there's no hover action, and it also waits for the component to expand. The collapse method looks a whole lot like the expand method. Nothing happens if the component is already collapsed. But if it's not, and it's a hoverable control, it hovers the control using a JavaScript workaround if it's configured to do so, clicks the control, waits for the component to collapse, and if it's not hoverable, it'll just click the control and then wait for the component to collapse. So hover over control, basically you pass the control and the used JavaScript. These are defined on the class itself. So if use JavaScript is specified, I have a Lambda method that uses JavaScript executor to perform a mouse action that will hover over the control. And if you're not using this workaround, it uses the actions library in Selenium, which actually only works for me about half of the time. And I think it's about to get more troublesome because the native interface for Firefox is, that API is actually going away. And click control does the same thing. If you're going to use JavaScript, it uses a Lambda method that I've defined that uses JavaScript executor to do a click action on a specific web element. And if JavaScript is not used, it will and the control is hoverable, it uses actions to do the hover action. And then if neither of those things are true, it just clicks the control. So these are some abstract methods that anything extending abstract expandable have to implement. So these are all getters for the web elements and the Boolean values that specify whether or not it's hoverable or dismissible. If you want to customize abstract expandable, you would extend this class and provide your custom implementations for these methods. But I have a concrete implementation that does that if you're happy with the default. And isLoaded checks to see if this is a hoverable control element. And if it's not, then it'll check and see whether or not your assessor is displayed. And that's the default standard way of determining whether or not an expandable component is loaded or not. And then the default implementation has lots of Lombok getters. I can't use Lombok for everything because it expects an is prefix for Boolean values, and some of them don't have that. And then if you're using the default, you would have a toggleable visibility bean with all of the state specified that you would have used a builder to specify, and then it will set all of these values. It's a very simple component. I've omitted all of the getters here because it's just basically boilerplate code that you don't need to see. But this inherits from abstract expandable. So all of that behavior that's in the abstract class, which is default, will be used by this implementation. So the decorator is how you get new features without boilerplate. So a component can only inherit from one class. But as you can see, it might need to combine behavior from multiple component types. So pre-Java 8 interfaces allow for this type of combination, but you have a lot of boilerplate code because you have to implement all of those methods. So Java 8 allows interfaces that have default method implementation, so you can write an implementation for the method, and you can implement that interface and actually have to write nothing, and you get all of that behavior for free. So you saw that the abstract expandable actually implemented the pollayable decorator interface. So what this is that there's a provider that will provide some implementation of pollayable, and the default is the default pollayable implementation. And it implements all the methods from the pollayable interface, but it defers to this internal component that's hidden from view, and it appears to be just part of the class that implements this interface. And the reason why I have a provider is because I wanted to specify the getter for this internal component to be protected access, because I didn't want to break encapsulation and give access to internal subcomponents that you don't necessarily want your users to know about or interact with directly. And the expandable decorator extends expandable, and it uses the same mechanism. You have a provider that will return some implementation of the expandable interface, and then all of the methods from the expandable interface defer to this component implementation. So you get the polling timeout interval, the expand method, the collapse method, and then the state check methods for whether it's expanded or collapsed. So now you have menus. Menus also have a content container. They can be flat or expandable. And a menu component needs to provide a getter for the available options on the menu, and it needs to provide the ability to click an option. So the basic menu interface should be agnostic to whether or not it's expandable or drop down. You want to limit the amount of behavior you have in a basic interface. And then you can use decorators and marker interfaces to define a drop-down menu, which has the ability to get a list of options, click an option, but it will also allow you to treat it as an expandable component that you can click on an assessor and then display it, and click on the dismisser to hide it. And then the dynamically configurable option that is necessary for a menu would be the click action for clicking a menu option, because that click action can fail silently in a lot of environments. So the interface basically requires that you get a list of the options, have the ability to click one of them, and then the bean basically allows you to specify the list of web elements that encapsulate the options on the menu, and then whether or not you want to use a JavaScript workaround to click one of them for the environment you're running your test in. And then the configuration bean has a setter for that JavaScript workaround. And then the builder is like any other builder you've seen. You can set the option elements and then set the Boolean value that determines whether or not you're going to use a JavaScript workaround. So to get a drop-down menu, we do the same sort of marker interface strategy. It extends, the drop-down menu bean extends menu bean, and then the toggleable visibility bean. The configuration bean extends the menu config bean and the toggleable visibility config. And then the builder will extend menu builder and toggleable visibility builder. And you don't have to declare any methods. Basically, you're just saying that it implements the methods in all of these interfaces that it extends. So an abstract menu will take a bean to populate its state, and then the methods for get options will take into account whether or not it's an expandable menu. So basically, the way to know whether or not this menu is actually a drop-down menu is to determine whether or not it's an instance of an expandable, and that's actually on the next slide. So if it's assignable to the expandable class, you know that it implements this interface, and then you can cast this menu to expandable and then invoke the expand command. And so when you're getting the options, the get options method will take into account whether or not the menu needs to be open to get the options and then closed afterwards. And the click option will throw an illegal state exception if it doesn't actually exist on the menu. And it takes into account whether or not the menu is dropped down or not by checking to see if it's an instance of expandable. And if it is, it will expand the menu before attempting to click. So there's some abstract methods that are required for any concrete implementation of menu that are defined in my concrete implementations, but here they're provided as abstract methods to be implemented by a class that provides a custom implementation. So in order to build the actual option class, I use some fancy Guava reflection API that's useful in certain limited circumstances. This is one of them. It's an abstract class that'll be extended. It's not good for everything, but what it does save a client of this class is the need to specify yet another setting. You don't have to say, here's the class type of my option. You can just declare it as part of a generic type parameter, and it'll figure out what the runtime class is. But I left that out here because I thought it was just too much to add. So this get option class actually uses this fancy Guava reflection API to query the generic type parameter for its runtime class type. So the basic drop-down concrete menu, this is a default implementation, extends the abstract menu, and it implements expandable decorator. So this is how you get all of the behavior of a menu, but you can add the behavior of an expandable component without actually implementing any methods. All you have to do is declare a provider, and in the constructor, you basically instantiate your provider with an instance of the default expandable implementation using your state bean. So the state bean will have all of the assessors and hoverable behavior are not defined in that. So you get all of that behavior and you don't actually have to implement any of those methods, which is nice. And is loaded for a drop-down menu will defer to the expandable components is loaded method, which is basically to say if you can see the assessor method for a non-hoverable control, then it's loaded. So I thought I'll just give you an example of a class where I actually needed to use this. So this is our customer configuration portal. So this is like a fake company with a bunch of customer configurations. And you can see all of the configurations listed here. Some of them have an action menu, which is, pardon? Oh, you can't see it. I'm sorry. I thought you could. All right, I'm not sure how to make that visible. Well, I have a list, basically it's a table with a list of rows, and some of the configurations have a drop-down action menu and some don't. But you can't tell whether or not there's actually a drop-down menu until you hover over that column. Thank you. So this is a fake company with customer configurations. Some of them have this action menu, and some don't because they're from an older product. And this menu has some strange behavior. It's sticky. So if you hover and click and expand it, that state stays. So every time you go back to hover that menu, it's still expanded. So this was an education on how to define an abstract expandable component that sort of could handle all of these different flavors of, state and behavior in only one class. So I have a class where I use this expandable component or this drop-down menu implementation for my action menu. So what I do is I have a method that builds this action menu. And this happens only when a user first tries to interact with it. So I try to lazy instantiate everything in order to keep things fast. So if someone wants to check to see if the menu's there or if they want to interact with some item on the menu, I have a build action menu that uses the drop-down menu builder, and then it queries the configuration service for configuration by ID, and the ID is the property action menu. So there's a running configuration service, and you can check to see if there's a profile for this menu that's active currently. And if it is, it sets all of these Boolean actions, basically the use of JavaScript workarounds. And then I use the builder to construct it. And you can see there's a lot of things to set. But despite the complexity of this method, at least I don't have to implement all of that behavior over and over and over again every time I have a component that needs a drop-down menu. I have this implementation and this configuration being state being builder set up where I can just construct the menu and get all of this behavior. And then if you want to see how the configuration is actually specified, so I have a test suite. And obviously, I'm running it somewhere with some type of browser on some OS. So I query this service to get a driver of a specific type, which is usually set in the environment configuration file. And then I have a naming convention for my profiles based on the name of the browser, the version, and then the OS where the browser is running. So I get that, I create a file name based on those settings, and then I set the profile using that file name. And it's running in the background, and then as your components are being interacted with, I query this service to determine whether or not it needs to, or whether or not there's behavior that has to be done via workaround or some other environment-specific way. And if there isn't a configuration for your component that's specified for that environment, it just uses all the defaults. So that's where all of the configuration settings happen, and the configuration service is started by the test class that's actually running all of these tests. And I keep all of my configuration profiles in my resources directory under page object config directory, and you can see I have for my test suite here, I have one for Firefox 30 on Linux, and then I have a bunch for different versions of Firefox 38 on Mac. And whenever I'm running with a new version of a browser and I see that something fails, all I have to do is create a configuration file, simple JSON file, and use the ID for that component, and then specify my dynamic behavior. So for the property action menu in this particular environment, I had to click the menu option with JavaScript because it just failed silently in that particular environment. So that's it. I don't think there's a whole lot of time for questions, but if you have any, you can meet up with me after we leave the room. I think this is about 45 minutes now. So I hope this was useful. I know this was pretty complex. There was a lot of source code, but if you want a copy of the presentation, I can make that available. And when I get back to my job, I'll ask my boss again if I can open source this, because I think it could be useful. And I think there's probably less complex ways of doing things that I don't personally know about. But I think I might be able to make at least the source code that I have here in this presentation available, if not the entire library. But thank you for attending, and I hope this was good.